Okay, I'm waiting for you girls, okay? Okay, Tatiana, can you read the question, please? Okay, listen up, please. Okay, so everybody know what I'm doing? Number 62, page 187. Okay, Karthik, when's a function increasing? When does a function increase? When can you see a function increases? Okay, you guys really need to do some work. I feel I'm the only one working in this class, man. This is f prime. I'm not talking about that. Okay, I got to rub this in your face now, okay? Guys, remember the sparkles? Yes. Well, not even the sparkles. Right here. Guys, even remember this? Right out of your notes. Okay? That's the answer. Function is increasing when f prime is positive. Function is decreasing when f prime is negative. Wow, you got it. Okay? So, here. So remember f prime greater than 0 means function increasing. F prime less than 0 implies function decreasing. And f prime equals 0 really means either a min or a max. Now notice that the graph is of f prime. Okay, it's not f, it's f prime. So where is f prime positive? Where is f prime positive? What interval? What interval? Sorry, say it again. Negative infinity to negative 1. Is everybody okay on that? Yes? Okay. Where is the function decreasing? Negative 1 comma infinity. Is everybody there? Okay. Where is the function min or a max? X equals, well, wait a minute. X equals negative 1. I have no clue about what the y value is because I don't know what f is. All I know is f prime. Okay? Now, can you tell me whether this is a min or a max? Hang on. Is this a min or a max? Okay, back to the notes. Do you guys read your notes at all, ever? You remember the sparkles here? Was the one supposed to be a max and the other one a min? So which one's which? Hello? No, answer the sparkles first. Top one is min, okay, and the bottom one, max. Okay, so can you kind of look at this one here? So it's a max. Is everybody there? Because here the slope is positive, which means your function is going to be increasing. And here the slope is negative, so you mean the function is going to be decreasing. So that gives you a max. You guys with me on this stuff? This is all out of your notes. Read your notes. Watch the YouTubes, man. Watch them. Okay, Laura, question.
I'm very involved in how we know that it's increasing.
Okay, see how in this part of the graph here, f prime is positive? Because this is a graph of f prime. Every value on this thing has a positive value to it. Huh? No. Okay, listen. When you say a function is positive, you're looking at the y value of it. Okay? So we are looking at the y value on this part here. On this part here. What's the y value on this part? Positive. And therefore the function's increasing. Okay, so remember this, okay, you should know this by now. When you say a function is positive, you mean the y value of it is positive. So we want the y value of f prime, so right here the y value of f prime is positive. Every place you go here on the y-axis, it's a positive number. Right? And then on this side here, every y value on that thing is a negative number, which means that f prime is negative, which means it is decreasing. Okay? And then this comes from the Sparkles theory. Okay? Does this make sense or not yet?
Yeah. I guess the sparkle thing.
Well, the Sparkles thing, if I go back to the... Well, when a function changes from increasing to decreasing, obviously it's going to turn a corner. Right? It's increasing and then decreasing. So it's going to turn a corner. You with me on that? So if a function, the thing that's probably confusing you here is there are two things here. There's an f and there's an f prime. This is given to you. I want to know the behavior of that. Okay? So the behavior of that, remember your line was going like this. Your f prime line was going like that. So at some point, this was -1. This part was all positive y values. So then the function was increasing because f prime positive means increase. And then from here on out, okay, it's negative y values, so f prime is negative, which means the function is going to be decreasing. And if you shape it like this, then you can see it's a max. Okay? Sorry? It's got to be a max. And if it's negative to a positive, it's got to be. I think the best thing to do is just have these icons in your, just like you have your delete icon, your trash bin and all that on your iPhones to delete email and all those icons that you have. That's what you really want to remember is these icons. Okay. This is a max, and you can see that here the derivative, and I did this in class with you, the derivative, the slope of these blue lines is what? Is positive. And then on the other side, the slope of the red lines. So you really want to run this in your memory here. Okay? And this one's got to be, okay. This is negative. Therefore, it's decreasing. Okay? Right? Okay, next example. Number 87. Okay, Jonathan, you want to read number 87, page 189. No, you got to read this paragraph, dude. Okay, so this should help you do number 85, okay, this example. All right. So it's pretty involved, okay? So your distance function, s of t, is equal to t cubed minus 5t squared plus 4t. Plus 4t. That's your distance or displacement function, okay? Distance or displacement. Anybody remember where the velocity function comes from? What do you do? Velocity function? Exactly. You differentiate this. S prime of t gives you the velocity function. And so, Teddy, do that. Fantastic. Good job. So this would be your answer to part A. Find the velocity function of the particle at any time t greater than or equal to 0. Okay? So there is your velocity function. Okay? Now a bit of convention, okay? If s prime of t is positive, then you're going in the positive direction. If s prime of t is negative, you're going in the negative direction. Okay, that's convention. Okay? You guys with me on this? Now, how are you going to, now you know that this is your velocity, right? How are you going to know where the function is positive and the function is negative? What do you do? Sorry? Sorry? Not critical numbers. What do you do first? You only want to know is where the function is. So it's got nothing to do with critical numbers, nothing to do with min-max, nothing to do with calculus. How do you tell if a function is positive or negative? What do? You graph that. You graph that. So let's do it. Okay, so it should look like that. I'm going to kind of zoom in a little bit more here so get a bit of feel for it. So I'm going to change my window to, let's just say 5. Okay, notice that this is the velocity function. Okay, this is the velocity function. Everybody get the same graph? Yeah? I've changed my x-min to 0 because x is really t, time cannot be negative, and I made my x-max to be 4, 1, 2, 3, 4. Okay, so Laura, I want to see if you've really understood this. Now, what I want you to do is come to the board and trace that part of the graph where the function is positive. So you say the red pen for the parts that the function is positive.
Red is positive.
Red is positive.
Oh. That. Oh, that's not
Okay. I'll just stop there for a minute. Stop there for a minute. Remember, again, function is positive means the y value. Is the y value on this part here positive or negative? Okay. And then, there you go. And then use blue for negative.
You're just trying to trick me.
No, I'm not trying to trick you. I just want to make sure that. Sorry?
Wait, but.
No, we are not looking at.
Okay.
It's got nothing to do with calculus whatsoever. All we are doing is looking at where the function is positive or negative, which is algebra 0 stuff.
That positive negative.
This is the derivative.
But that's the derivative.
Yeah, but again, remember the blue lines here is what I'm doing is the derivative.
Okay.
Yeah.
And so
This particular question right now has got nothing to do with calculus at all. Okay, it's just telling you that once the only calculus part comes from going from there to there. That's all. Then once you get a function, then you have to decide where the function is positive or negative. Because when the function is positive, you're moving in the positive direction. When the velocity is negative, you're moving in the negative direction. That's what I want to find out. So remember, this was my velocity function here, right? That was my velocity function. So red was positive. Did we agree on that?
Yeah.
Okay. So that means it's going to be in the positive direction. Yes. All right. So can you guys go find me this time here? How do you find that? Calc 0 and Madison, dare you do it. Dare you take your golf club out. Emily, you got it already? 4 decimal places? Yeah, why give me 0.5? Wait. Huh? your gaming equations?